Welcome to the third part of the presentation series, Introduction to Sampling for Mineral Processing. In this video, we will look at sampling errors, which will include delimitation and extraction errors, bridging, cutter issues and multiple cutters, and back pressure. In the Sampling Basics presentation, we discussed the golden rule for sampling, which states that for correct sampling, all parts of the material being sampled must have an equal probability of being collected and becoming part of the final sample for analysis. It was also mentioned that in order to take a representative sample, the total stream should be sampled, the sample cutter should intersect the sample at right angles to the flow, the sample cutter should travel through the stream at a linear and constant speed. If these rules are not adhered to, then sample bias can easily be introduced. A bias is a statistically significant difference between a single measurement, or a means of a series of measurements, and its value in a certified reference material. Its value measured in accordance with a recognized reference procedure, or its value measured against a certified weight. This is a systematic error. It is the sample supplier's role to minimize sampling errors that cause bias. Increment delimitation or extraction errors that can cause significant bias may be caused by, for example, incorrect cutter geometry, cutter speed too high, cutter speed not constant, insufficient cutter capacity, incorrect sampler installation, and others. One cause of incorrect increment delimitation is taking part of the stream all of the time, such as a fixed cutter or probe in a slurry stream. This is the mode of operation for process control samplers, such as launder or pressure samplers. This can lead to a sample bias due to segregation. In the case of fixed cutters, correct increment delimitation is only possible with completely homogeneous conditions, such as liquids with no suspended solids. Here are some examples of taking part of the stream all of the time: nozzles and cutters. These kind of samplers are usually only suitable for supplying a sample to an analyzer, such as an XRF or particle size analyzer. Here are a couple more examples of taking part of the stream all of the time. A hole at the bottom of a pipe. This would be coarse biased. A submersible pump placed in the flotation tank or a launder. Another cause of incorrect delimitation is taking part of the stream part of the time, such as grab sampling. As an example, a shovel on a conveyor belt or a cup in a slurry discharge launder. Correct increment delimitation is only possible in this case with completely homogeneous conditions, liquids with no suspended solids. Here is an example of taking part of the sample part of the time. In this case, the operator is unlikely to select the larger rocks, which will create a bias. The sampler's cutter can be a cause of incorrect delimitation. This could be from poor design or manufacturing, or the cutter edges could be worn, damaged, or there could be solid accretion near the outer edge. Here you can see that the material collected in the shaded section should not be included because the cutter blades are not parallel to each other. In this case, the sampler's cutter may have a solids buildup near the center of the cutter. Here you can see that the material not collected in the shaded section should be included. Again, the cutter blades are not parallel to each other. Another cause of incorrect delimitation is poor cutter alignment. The cutter may have been misaligned during installation, the cutter may be too short, or the sample trajectory may have changed due to process fluctuations. Here you can see that a portion of the increment is missed. For rotary Vezin type samplers, poor cutter geometry is another cause of incorrect delimitation. This could be due to the use of non-radial cutter edges. Maintenance departments may replace blades, assuming they should be the same as other types of samplers, such as linear cross-stream samplers where the blades are parallel. Here you can see a section is added to the increments which should not be there. This is an example of a cutter blade contamination where you can see a buildup of a particulate blocking part of the cutter and biasing the sample. Also, this buildup could break free and enter your sample container, resulting in a contaminated sample. Here we have an example of worn cutter blades. The blades are no longer parallel or even, and some sections will take more sample than others. This is an example of bridging or buildup. Again, the blades are no longer parallel or even. In this case, some sections will take less sample than others. The effects of bridging or buildup can be reduced by including a water flush system in the sampler design. This linear sampler has several problems. There is solids buildup on the cutter blades, a cutter blade on one side is missing, and there is insufficient capacity in the cutter and discharge pipe, which may result in backflow or sample being rejected. This rotary resin sampler also has several problems. The cutter blades are parallel, whereas they should be radial. Also, the cutter blades have different angles and heights. Here are some problems with samplers which use multiple cutter technology. Their theory is not really discussed here. They can have high maintenance. They take more sample volume versus single cutter designs. Multi-stage systems can have many sets of cutters. Each cutter must be identical to prove their theory. However, they will wear at different rates. The theory is not practical or realistic, as this video shows. Here you can see segregation occurring before the cutters. Backflow out of the cutter is another extraction error. Here you can see the sample flow entering the cutter is higher than the flow of the sample leaving the cutter. This could be due to insufficient capacity of the cutter, or the discharge diameter is too small, or maybe there are obstructions or damage to the discharge pipe. Process control samplers, blunder and pressure pipe also have these backflow issues. This will be discussed further in future videos. This completes the sampling errors section of the Introduction to Sampling presentations. We here at Heath & Sherwood hope you found this useful and informative, and please watch the rest of the series. If you require more information, you can contact us directly.